There we go. Good afternoon and welcome to this month's episode of the High Performance Homes team. So far on screen, we have Mike Battaglia in Ohio and Vicki Wooster, one of our fellows in Oregon. I'm going to go ahead and share my screen here. We kind of just put together a bunch of topics. It's the start of a new year, our first show in 2025. Happy New Year, everyone. Feel free to go ahead and join us online if you have microphone and a camera. But we were wanting to talk about some of the products that you've discovered that are coming up. Maybe they don't exist yet, but they're in development, something that is on the horizon. Garrett sent out an email, I think last Thursday, that talked about, and I've got a few notes on all of these, carbon negative concrete, phase change materials, graphene-enhanced materials, smart solar inverters, transparent solar panels, building information modeling that has AI, silica aerogel, which I found very interesting, bio-based insulation, and prefabrication, which can include 3D printing. So those are kind of, we don't need to hit all of these. I've got one to start off that I think is pretty cool, and it's that first one, carbon negative. And this is Ty Durham. Ty Durham is a 6th grader, and he has created a science fair project. Remember those? And I wonder, someday I'm going to have to do some research to find out how many science fair projects have actually turned into real products, because Ty has a vision of creating living bricks. 8% of our carbon emissions are created globally by the creation of concrete. That's 2.5 billion megatons, I think, is how they measure that. And so there's a lot of work out there to change the way we manufacture, and all the carbon's being created by the way you process the lime and then put it in the kilns. I think they're circular kilns. I think they spiral it. I forget. But when they're actually creating the concrete mix itself, that's where the production causes the carbon footprint. So what Ty has done is he's invented a living brick. He's experimented with wood chips, sawdust, what else? Manure. But everything that he's been experimenting with, he's been using mycelium, which I guess is harvested from the mushroom roots. So that was kind of an interesting read. What do you guys know about new concrete? What's happening? Whether or not there's something on the horizon that we can have as a strong substitute for concrete that doesn't take as much effort to create.
Well, as the crickets chirp, the concrete is probably, for the most part, everybody would recognize that concrete is one of the strongest building materials we would have. And there's limitations to everything. I'm not sure. I mean, this kid's invention sounds pretty promising. I guess it's a matter of what its bearing capacities are, what its long-term capacities will be. But that's something that every product seems to have to go through those growing pains. My hat's off to him for at least thinking that. Most kids would think about a science project on how a volcano erupts and make something explode in their kitchen first, But the concrete, it is like many other materials, I think. It may have a high carbon footprint, And then as you look into various green programs and LEED programs, some of the issue on this, whether it's feasible or not, is transportation and the location of the material that it has to come from. So it's brick, for instance, clay brick may have a long-term resilient effect, but if the brick that the client selects or that a designer selects for a project has to come from 1,000 miles away versus a brick product that comes from 4 miles away, the one that comes from 1,000 miles away is not as green as the local one. So the same goes with concrete.
Well, concrete comes in a liquid state, and you place it. That's like the only thing I remember from back in the 1980s when I studied for my contractor's exam. And by gosh, they actually asked me this question too, that concrete is placed, it is not poured.
Yeah.
But just by virtue of, how it comes and how quickly it can set, the concrete plant can't be very far off in order for it to be used as a slab or, wall material.
Right.
I know, whenever there's a new bridge that's being built in our area, and I hear from the contractors locally every time there's a big project like that, the concrete companies like shut off everybody else and they work for DOT 24/7, just producing concrete around the clock for huge projects. And I remember reading too, I think it's the University of Michigan, one of the universities in Michigan, where they're working on creating electrochemically produced calcium carbonate. And apparently the calcium carbonate is the glue that holds it together in the concrete. And that's what they're extracting from the lime, maybe. And so by being able to produce it in the laboratory, they're not using these high heat kilns that require a lot of fossil fuel to get to temperature. It's kind of like, I don't know, maybe it's not like, but it sounds like they're starting to make diamonds. They've got laboratory diamonds that apparently are the same quality or better than actual real diamonds. They're using a similar process. It's just they're applying thousands of years of heat and pressure in a matter of months instead of decades or centuries. Hey, Larry, thanks for joining us.
It's not
what do you got
CZ.
to add in on this?
It's not a CZ. It's a real diamond.
That's what I'm told, that it's got the same chemical, but that could be just a sales guy.
Well, I have some friends that had a good line of pawn shops, and so they had diamond checkers. And you know how a diamond checker works?
Is this a dad joke?
No, it's just for real. Okay, it's electric, and they touch a probe to it, and so a diamond will conduct electricity faster than anything known to man. So if it doesn't ping instantaneously, then it's not a real diamond.
Well, what do you know about carbon neutral concrete?
Carbon neutral concrete. I don't know. What is it?
Well, have you heard of concrete that's pervious? I've read about this as well.
Yes,
that you could
I do
use
know
for
about that.
driveways, and it doesn't. You don't have to use it as 100% impervious when you're doing your landscape calculations. How does the impervious concrete work?
It's it's got some chemical in it. I was trying to think of the name of it, but it lets the moisture just wick right through it, so it doesn't hold any rainwater, and so you don't have to count it on your impervious calculations.
How do they calculate like brick pavers, or does that get any kind of credit as far as being impervious?
Um, well, personally, I think that their whole method of calculating impervious is skewed. Um, I mean, a deck, okay? All the water on a deck is going to go straight in the ground. It might take it a few minutes longer, but in Rusty, okay. Hey, Rusty, I got it figured out. I'll give you a holler back.
Our
So,
Rusty?
yes, you're Rusty.
How about that?
So, I so a deck, so the water goes through, but you count it as 50%. I guess because it doesn't go quick enough. I'm not sure.
Huh.
I don't know
Interesting.
how's it done in Florida or Ohio.
Well, I mean, you think about, we have lot coverage regulations. I know my lot that my house is sitting on is 50%. I can do 50% pervious. But I mean, even the house itself has a roof on it that has gutters, and the gutters throw the water off onto the ground. So I'm not sure that the calculations are 100% directed at just water flow as much as it might be other environmental conditions that are being caused by having something covering the earth. Does that make sense?
Kind of. But if it's hitting a roof and then it's coming down a downspout, it may be directed. I don't know. So,
I mean, the zoning department may just be more concerned about not having a site 100% paved over because of landscape beautification as opposed to water runoff.
Yeah, they're talking about two different things there. One is overall ground coverage versus water distribution. Overall ground coverage, neighborhoods will try to keep as much of the green space around the house as possible, just as aesthetics issues. But the water issue for pervious or impervious spaces is a matter of water control and runoff into the utilities or to a neighbor's yard. So it's two different types of water runoff spaces.
All right, here's another product that I looked into. It's called the Allison Air Gel Blanket. Now, when I did research about silica air gel, I found 4 companies: Aspen, Aerogel, Cabot Corporation, Aerogel Technologies LLC, and then Gongdang Allison. And I just had fun saying Gongdang, so I was like, that was the one I gotta spend time looking at, is Gongdang. So Gongdang Allison has created these blankets that are, it sounds like it's a glass fiber type material that's extremely light, water resistant, and very highly, it's a high insulative value, I guess is how would I say that? What's the right way to say that a small amount of it is worth more than a lot of something else, whether it's cellulose or blown or bat. My guess is that it's very expensive too. Anything that's glass fiber. I mean, you think of, I remember my dad had an underground construction company, and he hit a fiber optics line, and it cost $700,000 to fix. Mm-hmm. Fortunately, the people you call that's supposed to locate the lines, they didn't locate that one, so he was off the hook. But what are some of the technologies? I know we hear a lot about like foam. But I'm not hearing great things about foam. I know there's good foams and bad foams. What's the insulation material that's on the horizon that you guys know of?
Well, I haven't heard of any new insulation materials coming out. I mean, there's obviously there's foam, spray foam. Then there's the fiberglass, of course, and there's the rock wool. There's blown and bats and the rest of that stuff. That material you were just showing, that looks actually very promising. Sometimes I wonder where products like that come from. Did the product result from, for instance, the space program? Because you're not going to load up the spaceship and its construction with spray foam, and you're definitely not going to be throwing a bunch of fiberglass there. I mean, it's so cold out in space, and they need light, thin material to do those things. It's just like a lot of other things. Composites are starting to take over a number of the common building products, and I would consider that material more of a composite. But the technology is out there. How they're doing it, I don't know. They got composite beams that take the place of steel beams. You got composite decking, of course. You got composite studs. You got all kinds of different materials that are being tested. And I kind of wonder how much of it is tested because of the need and because of the opportunities out in space that they can test things like that.
There's a newsletter. I get a lot of newsletters that I've signed up for, more than I can read. And there was one that I was thumbing through yesterday that had a link to an article that had a list of all the stuff that's been created by the space program that we use on Earth. But I didn't get time to. I wish now I would have at least thumbed through it, but I didn't even click the link. I was afraid of going down a rabbit hole.
Yeah.
On the insulation, there's a cellulose insulation. I was a big believer in that for a while. It had borate in it, which no insect or rat or anything can live in that. So that did away with having to treat your studs with termite that spray, and I don't do that anyway. I have another method, but I think that foam is the way to go. I've only heard bad of a little bit of bad, and there's loose fill and there's tight. But think about a coffee cup. A coffee cup is only a 1/16 of an inch thick. Coffee's 160 degrees. That lady that sued McDonald's, because she burned herself and got $1 million. It was in a it was in the 1/16 of an inch coffee cup. So, why is there a rejection of spray foam?
Well, I don't know. I guess because like the coffee cup is something that I've heard some people say that you throw it in the waste, and it goes into the dump, and it'll be there for 1,000 years. That's like I was doing some reading about bio-based insulation, where they talk about using cork and hemp, wool, which Andrew, also threw in rock wool in the chat when we were mentioning different options, straw. But we've also made the buildings to where you have to do air blower door tests. So we've got a building or a house that's completely sealed. What are we creating? I mean, it seems like we have to improve the air quality, but are we chasing our tails? Because what we're doing is putting products in the house and then closing up the house that are emitting toxins.
That kind of goes to some of the concerns about spray foam. or any foam product that goes back to even like the formaldehyde that was in cabinets for a while, or formaldehyde was in certain materials. And yeah, we are kind of chasing our tail. We have to build a tighter box, but then we create indoor air pollution, and the indoor air pollution needs to be rectified. So we have to buy more electrical equipment to clean the air in the house because we've made it so tight. So yeah, there'll be a balance sooner or later, but I don't know when and where that's going to end up being. You're sometimes just not going to know the difference. We build tight houses, and now and it still happens. In some places, they still have the whole thing. You have to have a radon mitigation process because we're trapping the radon in the house because they build the house tight. And radon is not something that you have a electrical device like a smoke detector or a CO2 detector that's going to pick up radon. So you don't know if you need it or not. It's just based on whatever area and region you live in. So yeah, we are kind of chasing our tail. How to resolve those, I don't know. But spray foam has had a history where people would say it off-gassed, and that caused problems. And the off-gassing as an indoor air pollution. Spray foam, some of the early ones would just ignite like crazy and just burn.
No. The foam won't burn. It will not burn.
Initially there was issues with the spray foam, and people were saying it would burn. And you're still not allowed to leave it exposed in a living area. It has to be covered. So
from the looks of it, I'd rather cover it anyway.
Yeah, the looks of it. But there are the foams that have to meet. If it doesn't meet the ASTM test, I think it's the 75 ASTM 75, and there's another one for smoke development. It may not burn these days, but if it smolders, it has a black smoke with it.
We got a comment in the chat about the foam being a pathway for termites.
I haven't heard of that.
They use EPS foam in structural insulated panels, SIPs. Termites and carpenter ants don't eat the foam. They don't go through that. I haven't heard that termites go through that. And again, there's different types of foam. Yeah, Deborah.
I just want to point out that the closed cell foam is extremely strong, and it creates quite an air barrier. And right now, it is probably what's going to save my bacon in this lawsuit I've been hit with, because the builder did 1 inch of the closed cell foam throughout the entire house, and the client is trying to say the house isn't strong enough, but I think this is what is going to save me. So closed cell foam adds a lot of lateral support. It's really good for that. It's expensive, but you don't need a lot of it.
What kind of a lawsuit are you in?
A house that I drew back in 21, the homeowner decided to sue the builder and 18 other people, everybody that touched the project.
Yeah.
So, they've got 145 pages of accusations. And what they were trying to tell me is that I didn't have strong enough lateral support. And this is part of my argument that yes, I do. And not only that, but we have this 1 inch of closed cell foam which doubles the lateral strength of the structure.
I wouldn't count on foam to be lateral support. I mean, everything is a contributor to the home, even the paint. But I'm not going to count on foam anytime. It's going to have to be a mechanical or a lead-in brace or a sheeting, something of that nature. I'm not going to count on foam.
The entire structure was nailed for shear, so it's all 1/2-inch plywood. Well, 15/32 OSB. It was all nailed at 6 inches on center and along the edges and in the field. And our anchor bolts are at 4-foot centers instead of 6-foot centers. So, and it's a stepped foundation, so it's a 1-story with a walkout basement with a lot of shear panels added.
This kind of gets off of our topic, but this would be an interesting conversation to have a little bit sometime in the future too.
I'd love feedback because this is looming over me in a really ugly way.
One extra thought on it. Have you engaged with a structural engineer for review of the plan and the details?
I haven't. My lawyer wanted me to be my own expert.
No.
So I dug through all of the codes, and the engineers that they hired as their experts ignored the actual components that we used to say that it was only good if that was this part of the code, but they ignored the other part of the code.
Yeah, my recommendation is get your own structural engineer. I don't know why an attorney would tell you not to engage with a structural engineer since the litigants have already done it. It's your word against a structural engineer. And if you have conflicting areas, their courts are probably going to lie towards the one that is the registered design professional structural engineer. But this would be an interesting topic to do at another time. But we are running into these issues with materials and wall bracing and other issues like that, because they're but they're being tested. Fortified Homes specifies a number of metal connection pieces, whether it be a truss brace or a tension strap or a shear wall detail. They're all engineered out to do a specific job, and that's it's something that is taking over a good part of our construction methods.
Well, I think that some of the Simpson X bracing that was galvanized metal was I thought that was good. And then there's also the what's the name of that V metal that you just run your skill saw down the studs and knock this V in there. Okay, what we have up on the screen now.
No, this has nothing to do with what you're talking about. It's another one of the new products that we found that we thought we would research a little bit, and it follows under the category of phase change materials. And the little bit of knowledge I have about phase change materials is that there's a byproduct when a material changes from like solid state to liquid state and liquid state to solid, that can be a benefit to the insulation of the house, whether it be cooling in the winter or warming in the summer. I remember being a young kid, and we built houses then in Florida, South Florida, that were concrete block that were just painted over the block. There was no insulation, there was no furring strips, no gypsum board. And I remember having my bed up against the wall, and I could lay against the concrete, and it would be cold in the summertime and warm in the winter, because it would absorb the heat during the summer, or I mean during the winter. I don't know why it was cold during the summer, but it just seemed colder than the room temperature. Anyway, that's kind of the best example I can give from history of a phase change type material. So I discovered Noff board, which is a substitute for gypsum board that is made with small paraffin wax BBs. And so their shtick is that Noff Comfort Board is a revolutionary new plaster board which significantly reduces or completely avoids the energy consumption of conventional air conditioning and heating in a building, resulting in both energy and cost savings. And there's a little profile. Their tagline is thermal mass without the weight. Then here's where it talks about the microscopic balls filled with wax. So I thought that was kind of interesting. As far as I know that I've also been in buildings too where they would construct a wall in front of a big plate glass window, that the intent was for that wall to heat up during the day, and then when the sun would go down, it would emit that heat through the evening and help warm the inside of the house.
Yes,
I've also seen barrels of water that were in the attic that kind of did the same thing too.
Right.
You are talking my education, because my degree was in passive solar, and several items. What you're talking about is a tram wall. It was developed in France, and it's great, except that it does block the south light, which in really hot areas, that's not a bad idea. But in cold areas, that is a bad idea. One thing about the phase change, when I was in school, which admittedly was back in the 80s, phase changes do break down over time. Now, I don't know if they've developed something new that doesn't break down over time, but the phase change salts that they used to use, they would break down over time and have to be replaced. So they were using those like in greenhouses where they were trying to keep them heated without any other source of heat. That was the issue, was that they had to be changed. And there was some other point you made, and now I can't remember what it was. But anytime you can put mass into a structure through like having concrete slab or anything that adds mass, it will help to balance the temperature from the highest heat to the lowest heat, because heat will always go to the coolest area.
The tram wall, I always thought that was going to be a very progressive application to construction. It made a lot of sense. During the winter months, it would heat up, and then the temperature would then radiate out of that material. During the summer months, it all basically boils down on sun control and knowing where the sun is and the overhangs of the house. Sometimes it's a matter of design to use it correctly, and it always had some possibilities. The barrels, I've seen the barrels before; those were huge to really do much. It would heat the liquid in the barrel and then radiate out of there. It's primarily for heat more than cooling. It was an interesting system.
We know that the code only addresses one thing specifically, and that's heat. Nothing about cooling. You do have to maintain. You do have to be able to reach 72 degrees, but it has nothing to do with cooling a house. You do have to be able to heat one, and I really was thrilled in the beginning, and I still am, about this high performance group that we have, and it's made me think about a lot of things, and I don't know whether he was just disregarded by a lot of folks, but the Larry that's right here in Austin, um, you know who I'm speaking of, Larry's build show or Larry's build time. He's about the best I've seen. No one knows of him. Are you telling me that you don't know of
I'm writing it down.
Larry's build time show, YouTube? Um, um, he's he's Johnny on the spot, and his AIA architect he is too. So, and then I read something in one of our minutes that was talk, because we went through that whole business about ventilating, subfloors and all that, and then the conclusion was to not to do it, and that is in my book totally wrong. Whenever you see these houses just blow up, I mean, they just, they're gone. Um, and they go, well, it's under investigation. Well, I can already answer your investigation that you won't figure out for another 2 months. But it was a gas leak. There was a gas leak, and it accumulated and blew the house to smithereens. So, I would be curious. Steve, you're a stat man. Check it out. How many houses get blown up because of gas, and how much of those blow-ups would not happen if we had ventilated subfloors? So, so we, or at least me, I'm kind of butting heads with the rest of the committee on, hey, no, we need ventilation in subfloors.
Larry, are you talking about crawl spaces? Ventilated crawl spaces,
yes,
or sealed crawl spaces?
Crawl spaces.
Okay. Let's be on the same page. Yeah.
And then there was even something put out in one of the letters that said, yes, it is the worst thing in the world to ventilate a floor. And in fact, we have an expert, okay? And here's his phone number, here's his website, here's his everything, And I didn't take the time to call him because I knew we'd get in a knockdown blowout, because it just does. Yeah, that doesn't make sense. It's nonsense. I'm sorry. I'll just take my stance here and say that's nonsense. We've been ventilating the crawl spaces since they've had crawl spaces.
Well, doesn't the building code give you provisions on how to do it either way?
No.
Yes,
no.
it does.
I don't know. Go ahead, Mike.
Yeah, it does give you provisions to do either way. If you ventilate it, you have to have, and it's somewhat based on region, but you have to have so many square feet of ventilation. If you're going to do passive ventilation through the crawl space vents, and then you get into the other side of that, if you do a vented crawl space, then you have to insulate the floor, especially because you have plumbing lines and you got drain and supply lines running through that floor. Your ductwork should be insulated because it's in an unconditioned space. So, and then there's a couple others where if you do a sealed crawl space, you insulate around and seal the perimeter, but you don't have to insulate the floor. But you do have to run a supply and return mechanical ducting in and out of that crawl space dedicated to the crawl space. It's not that you have to get that crawl space up to 72 degrees. You have to keep it above freezing, and you have to maintain that air circulation through that crawl space so it doesn't get moldy. Some of the reasons that the issue of doing a sealed crawl space was because people would see the opportunity. They didn't want their pipes to freeze in the wintertime. So they would go around their house and close the vents to the crawl space for the ventilation. They would close those vents thinking that it would keep the pipes from freezing, but then they would never reopen them and it became a mold factory. So yes, there are provisions for both. You need so many square feet of ventilated area if you're going to do it passively, and then you need so many air returns if you do it mechanically.
Well, thanks for that information. More research that I was doing about products to look for in the future was transparent solar panels. And I found, I must have accidentally closed the website. I wanted to have them, but I found a greenhouse that was built with transparent solar panels as the roof. So they were growing plants inside the greenhouse, but they were also creating energy with the greenhouse. So then I thought, well, is there anybody building windows that are solar panels? And that seems to be maybe not for housing yet, but in commercial construction seems to be a product that people are looking to develop or have developed and looking to market. So how do you feel about your windows collecting energy?
I personally think it's an awesome idea.
I do too.
About 5 years ago, there was a publication, I can't remember what it was in, but it was issuing testing of solar glass. It's either Michigan University or University of Michigan, one of the two, was doing a bunch of research on it. And the best they could come up with was a panel about 12 inches square and about an inch thick that was actually producing electricity. So I think that it's got all kinds of opportunities. Everybody wants glass in their house. Everybody wants a window. Everybody wants to lower their energy bills. And if you got the glass producing the electricity that's going to help heat and cool the structure and run the appliances, I think that's awesome. But the technology is probably still a little ways away for the general population.
Well, a lot of this probably is from the aspect of affordability for housing.
Yeah.
I don't think affordability and performance are on the same page. Okay. I mean, okay. I was working on the project, and there was a full bird colonel retired, and so I went to him. I said, "Hey, Colonel, I've got a question for you." And he said, "Well, if it involves money, then don't ask me, because all my decisions in the military, we don't have problems that involve money. Okay, our problems involve life." I said, "Okay, then I'll talk to somebody else, because this is a money problem." So I walked away from that. I guess one of the biggest takeaways that I've had from all these people from everywhere is a lot of what you draw depends on where you are, depends on where the project's going to be. That's huge. I mean, that's gigantic. And I listen to Steve every day on YouTube, and I got a couple of things I want to talk about later on that. But the biggest thing that's hit YouTube now is the fires in California. Devastating. So what have they come up with? Well, they've actually come up with a very fine screen wire that you can cover stucco, you can cover roofs, you can cover all kinds of things that will not let these sparks through to save the home. So it's a protective element. It's not I'm not going to call it a performance element, but it's a protective element. Would you?
I think
would
that
you put
glass, I think that
protective
solar
and-
glass would be awesome. Could you imagine being able to have a sunroof in your car, be the solar collector to power your electric vehicles? I think that would be a pretty good idea. You won't have to worry about a charging station. Today, like I said, it's like 3 degrees outside here in Ohio, but the sun is shining. I could be charging the batteries of my car with the sun if using the solar collector sunroof. Um, that way I wouldn't have to plug it into the house electricity. Uh, I think that this solar glass, I would love to see that happen. I really
They
would.
have solar bricks. They have solar shingles. They have solar everything.
I've heard of the
Right.
solar shingles for a while now, but I haven't heard of people using it. Is it not getting traction or does it not work?
No, I think it works.
It's not getting traction.
It didn't get traction as much as what they figured. Who was that developed? Was Musk the one that developed that? And the problem was his distribution wasn't working. So he bought a company called Solar City, and that's where you get your solar shingles from. Now, in the meantime, other people have come up with some other things too. There's a company out of California that was doing a standing seam metal roof where the panels themselves were the actual solar collectors. So you would put down each of the standing seam panels, and then you plug them in from underneath, and those were your solar collectors. And these guys are walking on it and banging it around. It was working just fine, but that was your solar roof. Your solar shingles. I looked at those. It was about 2 years ago. They were $1,000 a square.
No.
Okay, so at $1,000 a square versus $45 a square, there's almost no challenge to that one.
Does it come with a 30-year warranty like a shingle roof?
It's probably one of those depreciation issues, but the stuff will come up, and I'm actually kind of looking forward to the space program gearing up again, and even more than what it has been, because I think there's so much that has to happen for space exploration that can be used. The technology can be used on Earth. I'm really looking forward to that happening.
Well, Vicky, you joined us back on screen. Is that because you straightened out your technical issues, or do you have something on your mind? Oh, we can't hear you, but I know that you're unmuted. We've got about 10 minutes left, and I have a couple more products. Well, first I want to just plug the Midwest Solar Expo. I know nothing about it. They're not a sponsor, but in my research on solar windows, I discovered that June 1st or 9th through 11th in Chicago is the Midwest Solar Expo, if you're interested. So moving on to 3D printed houses. I was reading that Icon in Texas, which I remember, a few years ago, they were like the big innovator in Texas that were going to print hundreds and hundreds of homes using 3D printing and not prioritized, what do they call it? A concrete that they invented. But now they're laying off 100 workers. So what's the talk out in the industry about 3D printing houses? Is that something that's not going to happen? Is it just because there's maybe an economic lull in Texas that they don't need those 100 people?
I think that 3D printing is not going to work. Number one, it costs. I looked at it, and it costs $1.5 million to set up. Okay, so you're not going to just get a nail bag and order some lumber and start putting up a house.
Yeah, but that's not $1.5 million for every house, is it?
No, that's just to set up to start, squirting this mud.
Well, I can imagine it's probably $1 million to get your first McDonald's going too, but
Well,
what? But that's a good investment. Is 3D printing not? Is what you're saying?
well, no, I don't. If you've seen it work, it's like laying down 3-inch toothpaste, and it goes, around and around, and it's not very attractive, and it's got limitations, and I hate seeing us get away from the years of what I call attractive homes. Okay, not saying that a modern home is not attractive, but I like the columns and volutes and chair rails and crown mold's and all that. That's good stuff. But that's I have made more money in Austin with quote your modern construction than any kind of a traditional building. The thing that I saw with building designers is that they always, invariably, miss the HVAC. Okay, because all your modern houses are they're flat. They're flat tops. Or, they have a little slope to get the water off, but there's no room for any HVAC equipment, and so whenever the designer is going through doing this, they wind up having chases going through bedrooms and bathrooms and everything else to get the ductwork all around the home.
Well, with the 3D printing, I think that it's got some potential. And to Larry's concerns, I think that once people would be working with it more often, they should find the problems can be worked out just as any other design or any other kind of structural elements. It's you could do I know what Larry's talking about with the appearance of it when they pour the concrete walls. It looks like just a flattened tube line, but that's where design comes in, and you can do something with that to make more out of it than it is. It's long-term structure. Some of the oldest structures in the world are nothing but huge stone monoliths that will be around for centuries later. Well past the time of wood, well past the time of other things. So I don't know. I think that there's it's all open, but the cost of the equipment to set up, and you can't just move it to one site at a time. You'd have to do whole neighborhoods, I think.
Well, you hit the nail on the head right there whenever you said, stone, and it's been around thousands of years. If you want to talk about performance, okay, stone is the way to go. Not just as a veneer. As a veneer, that's good. It certainly is. It's better than wood. It's better than hardy. It's better than vinyl. But
it's really cold in the wintertime. Stone,
yes,
but as technology has improved, I think that we're on the cusp of a lot of new materials. Years ago, the tall buildings base walls were 12-foot thick masonry and stone, and then we came up with thin wall systems, which were steel beams and girders, which then the walls got thinner. It's just technology changes, and I think that's something we can embrace.
Well, like always, our hour has just evaporated so quickly. The last thing I want to mention is prefabrication. I think that's going to be I've been using prefabricated trusses in my designs for decades, but SIPS panels, this is Archetype, is a AIBD member who has started a company doing prefabricated segments of the house that he ships out in pieces using SIPS panels but rather than using OSB in foam, he's using steel or some form of metal sheathing in foam. So yeah, I think we're living in exciting times for our industry. I also believe that we're going to continue building houses the way we've always built them for years, but hopefully we can get more efficient with the materials because number one, a lot of the stuff we get comes from out of the country, and we have the risk of tariffs here soon. But number two, we just got to figure out how to get that performance that Larry wants at a price that most Americans can afford. Affordability seems to be an issue, and if we can solve that problem, we've probably answered the billion-dollar question. But my takeaways today are basically that there's a lot of promising things coming down the road. I learned that the phase change materials may break down over time. According to Mike, attorneys lie. And closed cell foam might be an alternative to concrete because it's strong. And Larry's build time show is going to be my binge watch for this weekend.
No, please do. Yes. Hey, and I want to ask you, whenever you had your Dutch gables and all that, like yesterday,
Right.
I've built 1 million of them. Okay,
A crunched gable.
I call it a crushed gable.
A crushed. There you go. Crushed.
Crushed. It's got a crushed in on it, and there's I developed quite a technique for doing that. And unfortunately, you can't patent those things, but it's really good. And then you mentioned briefly that a hip roof was it added strength to the structure. The real fact of the matter is the strongest home that you can build is a totally hip roof house. No gables. Gables are about as unstable as dominoes, okay, falling over. But a hip roof, it ties it all together. I mean, it locks it in. So if you want to build something that's going to be locked in, then it's going to be a hip.
The first house I built was a gable roof. It was a colonial Cape Cod colonial style. And when Hurricane Andrew was coming, I was packed and ready to leave because I had cut every corner that I could find in that house to get into it at 26 years old, 27, something like that. And so I'm surprised that house is still there. But every house since then has been a hip roof with small spans. But yeah, I agree to that philosophy. But there's so many styles that we build throughout the Midwest and the Northeast that are gable oriented. But there's ways to build gables too that can withstand the winds. I have to refer you guys back to whatever month it was we talked about storm rooms. I believe that episode is on our YouTube channel, on AIBD online. Somebody asked a question. Has anybody seen a SIP home with a hip roof? So I'm guessing that Dustin is referring to building the roof out of hips as well. And that's a good question. We will open up our next show with that, or we'll follow up with an email or something. But that's another, next to Larry's build show, I'm going to have to look up hip SIPs roofs. I know in Belize City, I designed a house 20 years ago that was all precast concrete, and the roof joists were an upside down T-shaped. And so we had to create, and it was a hipped roof design. So we had to design like what you would call the hip jack, or the hip, whatever that corner raptor is for the hip. Yep. And then the ridge raptor was all made out of concrete, cast in place concrete beams. And then these precast units set on top of those. And the reason why they were T-shaped upside down was you would lay 4 inches of foam into the T. They were placed 2 foot on center. The foam slid in between, and then we poured 3 inches of concrete on top of that. So
that system
when they're
is still in play. It's still being used.
it was interesting. And concrete laborers in Belize City in the 2005 were $75 a week. So that's why they used a lot of concrete there. But, and apparently armed guards are too, because we were talking about the security system for the house when we were designing it. And the client says, well, how much would that be? And I was like looking at, motion detectors. And he says, the client says, you know what, we can buy anything you can buy in America here in Belize City, but we can't get it all fixed. So he went with the armed guard, which was $75 a week also. And I thought that was pretty impressive.
I did mention one thing one time, and everybody said, I've never seen that, but I really think it's something that should be addressed. And it was the garage door. They are just
addressed how?
The way that the installation of a garage door is currently going in, at least in the area that I'm in. I used to frame a garage door wall where I had a 2x6 or a 2x4 or a 1x4, some kind of wood that ran all the way from the bottom to within 5/8 of the ceiling so they could slip sheetrock in there. And that member was to bolt the garage door runner to. Now they're just bolting it straight to the sheetrock. There's no wood there, and so
we bolted straight to the concrete block walls, but yeah, there's wood there. I've seen engineering where you have to have a certain number of jacks.
No, there's no wood there. I mean, you're sandwiching sheetrock in between.
That's a topic for a different day. But I know that there's variations on how to install garage doors, but. At any rate, thank you all for hanging out with us. We got to wrap up because if we go too long, it screws up the percentage of time that we have to be on for everybody to get their CE certificate. But I appreciate it. I don't remember what we had on store for next month's topic. Shame on me for not looking ahead, but I know you guys pretty much show up for, a great discussion no matter what it is. So thanks for doing that.
I think the next topic was sustainable building practices.
I know what I'm working on. The National Association of Home Builders and 15 states have sued HUD over the energy codes and how HUD is requiring that you meet, I think it's over and above. I don't know. I don't know what's going on. I just know that there's a lawsuit. NAHB and 15 different states have instituted it. So I've reached out to our contacts at the home builders and I'm trying to get a word back. So if I can, I'm going to arrange an interview with the attorneys at NAHB to explain what that case is about and what they're looking to accomplish. So that's what I'm working on. Good. Hopefully I can get their attention and they're able to talk about it. Sometimes there's lawsuits and you can't talk about, but maybe this won't be it.
Well, it's probably having to deal with the idea that they wanted an R60 ceiling and an R30 sidewall in various regions, zones. It probably has something to do with that. And they took the hearings, the energy code hearings, out of the normal ICC hearings.
They did that, but that's not a lawsuit against HUD. So anyways, that's what we're working on. We're like Vicki points out, by the time we meet again, I think we meet the week before IBS. But anyways, if I can get a representative to explain that case to us, then that's my goal.
Great. Okay. Thank you all.
Thank you.
Have a great rest of your week.
Goodbye.